Hello everyone. Today we're going to be working on the Volume of Revolutions classwork homework from the last page of the notes. We're going to be working on questions 1, 2, 3, 4, 5, and 6. 1, 2, and 5 are no calculator problems. For these questions, we only have to set the problem up. We do not actually have to solve, so that's all we will be doing today. Remember, I am just a student. I do not have the answer key. I am not the answer key. This is just the way I do things when I think things through. So, let's get started. Question 1. We're going to rotate the region bounded by y equals 3, the y-axis, and y equals the square root of x about the y-axis. So we're going to rotate these equations around the y-axis. So I'm just going to set a little graph right here, and I know that we're going to be rotating it around this axis right here. And I'm always, for these type of problems, I'm probably always going to graph the function just so that I know how these things look. So first I'm going to draw y equals 3. It says the y-axis, which just means x equals 0, so just this one right here. And then the square root of x, that's just sort of a sideways parabola. So we're going to have 1, 1. And instead of 2, 4, like an x squared, we're going to have 4, 2. And then 9, 3, and so on and so forth. And it's just going to look sort of like that. And we're going to not find the area. We're going to revolve this around the y-axis. So we're going to have the integral, volume, equals pi, we're always going to have pi there, times the integral of the r squared, and times dx. The boundaries are going to be the difference in y. So the most bottom point here that reaches x equals 0 is 0. And the most up point y value is at 3. So it's going to be from 0 to 3. And then the right function, and there is no left function, there is no gap. It's bounded to the y-axis, so we're not going to subtract anything. And so what is this function? It's bounded by the y equals square root of x. But the thing is, we're rotating it around the y-axis, which means that our equation has to be in terms of y. So we have y equals square root of x. To solve for x, we're just going to square both sides, and we have y squared equals x. So that's what we're going to plug in here. And we have y squared dy. And that's all we need to do for now, since we are not actually solving. We just have to set this up. Question 2. We have the functions y equals 2x squared and y equals x cubed about the x-axis. We're going to rotate the region about the x-axis. So once again, we're just going to graph both functions and see what's going on. So I'm just going to plug in some values. Doesn't have to be perfect. We know that the 2x squared is going to look like a parabola. I'm going to plug in 0, get 0, plug in 1, get 2, plug in 2, you get 8, somewhere up there. And same thing on these sides. I'm just going to go like that. And we're just going to plug some other things, these same values for the x cubed function. Plug in 0, you get 0. Plug in 1, you get 1. Plug in 2, you also get 8, and it's just going to look something like this. And we're solving. We're going to rotate this region around the x-axis, around this axis. So, volume, whenever we rotate, we get volume of pi is pi. The integral, well, what's the leftmost region that they could intersect? 0. The rightmost, 2. And since this is around the x-axis, we're going to do the farthest equation from the x-axis, which is the 2x squared, squared dx, because it's around the x-axis in terms of x, minus the integral from 0 to 2, pi, integral from 0 to 2, of the other function, which is x cubed squared dx. There you go. Next question. Question 3. This one's a calculator problem, so we are going to pull up the calculator for this one. We have the equations 6 e to the negative 2x, y equals 6 plus 4x minus 2x squared, x equals 0, and x equals 1. So I'm really just going to plot the function, let's see, 1 and 2, 0 and 1. So we're going to have a line here, and we're going to have a line here. So the bounded regions is going to be somewhere in here. And then the 6 plus 4x minus 2x squared, whenever you put it into the calculator, remember, you can use a calculator for this, it's going to look something like this. And the 6e to the negative 2x, it's going to look something like this. Not perfect, but just something like that, just that you get the gist. And we're going to be doing this part right here. That's the bounded region. We're going to revolve it around the x-axis, which means we can leave the functions as they are right now, because they're in terms of x. And we're going to have volume equals pi. The integral, the rightmost part where they meet is 0, and the rightmost is 1. So from 0 to 1. Which one's the top function, the farthest from the x-axis? The parabola, the 6 plus 4x minus 2x squared. 6 plus 4x minus 2x squared. All of that is squared. Dx minus the pi, integral from 0 to 1, 6e to the negative 2x, and all of that is squared dx. Sounds great. Question 4. We have the equations x equals y cubed, x equals 0, and y equals 2, and we're going to rotate all those around the x-axis. So, since this is going to be a calculator problem, and we don't actually, you can't plug in things for x, we're just going to go ahead and solve x equals y cubed, and we're going to solve for y, which is just going to be y equals the cube root of x. Because to cancel out a cubed, you just find the cube root. And yeah, that's it. And we're just going to graph those. X equals 0 is just the y-axis. Y equals 2. It looks like this. And we have the equation x cubed, which looks something like this. Not pretty. These two intersect at some point. And so the area bounded is going to be this area right here. And we're rotating around the x-axis. So whenever we integrate, we're going to have it in terms of x. So we have volume equals pi what are going to be our boundaries? Well, it looks like they intersect at 0, the x value is 0 right here, so from 0. And then where do these intersect? They intersect at 8, 2, and we're going to be using the x value from that coordinate, so from 0 to 8, which is the topmost function. It is the y equals 2. So it's going to be 2 squared dx minus pi, the integral from 0 to 8 of the bottom function, which is the cube root of x squared dx. Okay. Number 5. We have the equations x equals y cubed, x equals 0, and y equals 2. And we're going to rotate this around the y-axis. So I'm just going to keep this graph since it's all the exact same equations. But now instead of rotating it around the x-axis, we're going to rotate it around the y-axis. And what are we going to do now? Well, we have to have all the terms, we have to have all the equations in terms of y, since we're rotating it around the y value. So we're just going to have the volume equals pi, the integral. Well, what are our y values? The bottommost y value is at 0, 0, where they intersect right here. So we're going to use a y value from there, and it's 0. And remember, they intersect this line, the cube root of x and y equals 2, they intersect at 8, 2. So now instead of using the x value from there, we're going to be using the y value. So it's going to be from 0 to 2. And now instead of the topmost function being used, we're going to use the rightmost function, which is the cube root of x. But here we're rotating it around the y-axis, so we want it in terms of y. So it's just going to be y cubed. And the y cubed is going to be squared, and it's going to be dy. And we can just leave it like this because the leftmost function is just x equals 0, so it's going to be the integral of 0. Or, in other words, it's bounded by the y-axis, so we don't need anything else. There is no gap there. And the last problem. We have the equations x equals 5 minus y squared and x equals 4. And we're going to rotate this around the y-axis. Okay. So, once again, this one's a calculator problem, so we can use the calculator to graph this. We have x equals 4. So that's 1, 2, 3, 4. It's going to be right there. And then we can't graph 5 minus y squared into a calculator. But if we solve for y, we can. And that's going to be subtract the 5, and then multiply by -1, and find the square root of both sides. You get the square root of x minus 5. Whoops. Nope. The square root of 5 minus x equals y. And now show my work just so that I can show you how I got this. We have x equals 5 minus y squared. Subtract the 5. X minus 5 equals -y squared. Multiply everything by -1. Negative x plus 5 equals y squared. And find the square root of both sides. So square root of -x plus 5 equals y. And that's just square root of 5 minus x. And there's going to have to be plus and minus so that we can get both sides of this parabola. And it's going to end up looking something like this. And the area bounded is this part right here. And we're going to rotate this around the y-axis. So we're going to have to make it go back in terms of y, which the problem gave us, but we just solved for y so that we can graph it into a calculator. So we have v equals pi, the integral. Where do they intersect here? They intersect at 4, -1 and 4, +1. So the y value from here, -1, and the y value from here, 1. What's the rightmost function? It's the 5 minus y squared. So we have 5 minus y squared dy minus pi, the integral from -1 to 1 of this thing, of the leftmost function, which is just 4. So 4 squared dy. And I didn't simplify. You can expand these out or do whatever you want to do, but I just kept it like this, kept it most simple. And also, you can just separate these into two integrals just so that you don't get confused, because sometimes whenever you square, you might want to square all of it together, like 5 minus y squared minus 4, all of that being squared. So like if you want to keep it into one simple integral, you would have to do pi -1 to 1 of 5 minus y squared minus 4 squared dy. You can't square all of this together. You have to square each individual one by itself. And okay, that was all. Thank you for watching.